Hello everyone, and welcome on this Apex Institute of Physics platform of e-learning, in which we are discussing the motion under gravity, and this is the second video in that series. In this case number 3, when the motion is upward projection, we will take initial position as origin, and we will consider the direction of motion, which is upward direction, as positive. So this is a positive direction and this is the origin, so we can say this is x direction, and so that's the origin from where we are projecting. Now initial velocity is upside, so that will be written as a positive. Upside initial velocity is u. Acceleration, we see the acceleration is always downwards, so this a will be acting downside. Since it is downside, so this will be having a negative value, so we will consider it to be minus g. And using the very first equation of motion, which is v is equal to u plus at, we will get the vertical motion first equation as v is equal to u minus gt, replace a by minus g. And when we use the second equation, s is equal to ut plus half at square, so displacement is h and a is minus g, so that becomes h is equal to ut minus half gt square. Similarly, the third equation, which is the combination of the first two, turn up as v square is equal to u square minus 2gh. Based on these equations, we can find out some other results as well. Some obvious points: when the particle is at the highest position, then we will find it will be momentarily at rest, so v will be equal to 0 at the highest point. So that's one information we can remember. Now in case in the equation number 1 we can replace v as a 0, then we can find out the time the particle will take to go up. So 0 is equal to u minus gt. From here, if we consider t, so t will turn up as u by g, where u is the initial velocity, g is for gravity. So that becomes the time of ascent. The particle takes to go upside or the maximum height. When the particle returns back on the same position, so that means we will find the displacement of the particle is 0. If we use this for the second equation, we will find this becomes 0 is equal to ut minus half gt square. Now if we simplify this, we will find from here there will be two values of t. One, t will be either 0 or t will be equal to 2u by g. So that will simply say 0 is the initial time when the particle was at origin, and 2u by g will be another time when the particle will be at origin. So we can say this is the time that is known as time of flight, and this is the time that we calculated earlier was the time of ascent. If we look both the times, then you will find the time to rise up is exactly half of the total time. That means time taken by the particle to go to the maximum height is same as the time taken by the particle to come down. That means the motion in the upward direction and the motion in the downward directions are very similar as far as the time is concerned. Now to get the maximum height of the particle or the maximum height achieved by the particle, we can use the third equation, and we can substitute in the third equation v equal to 0. If we use this third equation with v equal to 0, we will find 0 is equal to u square minus 2gh. Now simplifying this, we can find the h value, which is maximum height. Generally we write it by capital H, and this becomes equal to u square upon 2g. So that's another important results to be remembered. So this is the maximum height relation. So we have just proved the time of flight and maximum height. So this is upward projectile motion under gravity. Thank you.